Hello everyone. So continuing with the measurement of dispersion, we have completed range, interquartile range, standard deviation, variance, standard error of mean. The next two remaining are skewness and kurtosis. For learning about skewness and kurtosis, we should be clear with the concept of moment. So basically, we have learned that variance is equal to sigma x minus x bar square divided by n or n minus 1. Anything is possible. So this 2 is called as second moment. If the power is 1, it is called as first moment. If the power is 2, we will call it second moment. If the power is 3, we will call it third moment. And if the power is 4, we will call it fourth moment. So first moment, second moment, third moment and fourth moment. We should learn till fourth moment. So if sigma x minus x bar by n, this is first moment. This will give us m. In case of first moment, as we have learned earlier, that when we will calculate x minus x bar and we will sum it up, all these values come out to be 0. So for first moment, m is equal to 0. In case of second moment, as we are squaring it, so all the negative values will become positive and we will get anything positive number. So m would not be 0. It would be anything but not be 0. And it will tell us the value of variance. And if the third moment, similarly, like first moment, in case of third moment also, the negative values square up to be negative and positive negative value cube to be negative, and when we will do cube of positive value, it will come out to be positive. So net result of summing is 0. So m would again be 0. So and for fourth moment it will again be something not 0. So all the odd moments will give us the moment the m is equal to 0. This would be in the case of our normally distributed curve. So here, if our curve is not normally distributed, so that can be of two types. This is the normally distributed curve. One thing that comes is right skewed and another is left skewed. Like it is skewed in left, which is also called as negatively skewed curve, and skewing towards right, it is called as positively skewed curve. So when we will calculate, just 1 minute. So when we will calculate first moment, second moment, third moment and fourth moment, first moment would be 0, third moment would be 0. This second moment will give us variance, and this third moment will give us skewness, and this fourth moment will give us kurtosis, and this first moment will give us mean. So skewness, if skewness would be 0, that means it's a normally distributed curve. If it is m is more than 0, it is positively skewed or right skewed curve. And if m is less than 0, it is negatively skewed or left curve. This is called as skewness. One more thing, that in case of Gaussian curve or normal distribution, this point would be our mean is equal to median is equal to mode. So all the three values would be equal, and lie at the center. Whereas in case of positive and negative skewed curve, like in case of negative skewed curve, this would be mode, it would be median, and this would be mean. So in negative skewed curve, mode is greater than median is greater than mean. Whereas in case of positively skewed curve, this would be mode, then median, then mean. So one thing you should learn is that median would always be between mode and mean. So either mode would be high or mean would be high, but median would lie in between. This is an important question which is simultaneously being asked in various examinations. So you should learn that for Gaussian or normal distribution, mean equal to median equal to mode. For negatively skewed curve, mode is greater than median is greater than mean. And for positively skewed curve, mean will be greater than median will be greater than mode. This is the most important thing you should have to cram it. So the next, this is called as skewness. And for the formula of skewness is usually represented by M3, third third movement divided by second movement to the power 3 by 2. You don't have to learn this formula, but just keep in mind that Skewness formula is like this: third movement divided by second movement to the power 3 by 2. Next come our kurtosis. So when it is our fourth movement, it will give us kurtosis. So fourth movement, that means M would be positive. Usually M would be 3 for a normal distributed curve. But M can be less than 3 or it can be more than 3. This would be these three cases you should learn. Basically, kurtosis tell us the flatness or pickedness of our distribution. Like if our curve is like this, it is called a mesokurtic distribution, which will have the moment is equal to 3. If it become more large at the top, we will call it as leptokurtic. And if it become more broad like this, we will call it as platykurtic. So M would be more than 3 for leptokurtic, equal to 3 for mesokurtic, and less than 3 for platykurtic. This is called as kurtosis. So the formula for the kurtosis, the formula for skewness is M3 divided by M2 to the power 3 by 2. The formula would be for kurtosis is moment of fourth moment divided by second moment square. This is called as kurtosis and it is represented by beta. This is an important concept of leptokurtosis, mesokurtic and platykurtic. So in skewness, the direction of the curve change, either it will move towards right or left or Gaussian. Whereas in case of kurtosis, the height changes. So when the height change, we will call it kurtosis, and when the direction change, we will call it skewness. Next, one more important term is Carl Pearson coefficient of skewness. This you should learn. It would be represented by xk, Carl Pearson coefficient of skewness. This would be equal to mean minus mode divided by standard deviation. This is an important formula you have to learn and you have to straight away apply if someone asks you about the Pearson coefficient of skewness. So moving towards the file, this is what squaring. So second moment. So moment m r, if r is 1, it is called as first moment, and in that case moment is equal to 0. Odd number moment are always 0. And M2 would give us variance, M3 will give us skewness, which would be 0, right skewed, left skewed. This would be the formula for skewness, which you should need not to be learned by heart. Then next would be this is the shape of Gaussian curve. Then right skewed, positively skewed, negatively skewed. Then next it will vary from 0 would be Gaussian, and if it is less than 1, more than 1. If it is less than 1, if it is between 0 and -1, it is negatively skewed and moderately negative skewed. And if it is more less than -1, then it will be highly negatively skewed, and vice versa for the case of positive skew.